Put your hand on the ground right now. What's underneath it? Dirt? Rocks? Then what? The truth is, humans have sent spacecraft to Mars and built space stations, yet we've failed to penetrate the thin crust of our own planet. So what's stopping us? And more importantly, what did we discover when we tried? Part 1, the deepest drill in history. On Russia's Kola Peninsula, engineers carved their way downward for decades straight. They reached 12 kilometers beneath the surface, a record that still stands unbroken today. But what they encountered down there wasn't in any scientific textbook. Before the 7-kilometer mark, everything went according to plan. But the deeper the drill pushed, the more reality drifted from the calculations. Temperatures that scientists predicted would be relatively moderate exceeded 180 degrees Celsius, twice what the geological models had forecast. Picture the scene, a steel pipe weighing hundreds of tons slowly descending into the depths with a diamond-tipped drill head at its end. Under normal conditions, it cuts through granite like a knife through butter. But at 12 kilometers deep, granite no longer behaves like the rock we know. Under pressure, 1,000 times greater than atmospheric pressure, the rock acts like thick honey, creeping along the walls of the borehole and sealing it from within. The hardest part of this work was changing the drill bit. The process alone took an entire day of non-stop labor, because you first had to raise the entire pipe column. The surprise? In the time that process took, the Earth was literally healing its own wound. The viscous rock would flow inward and fill the gap, forcing engineers to re-drill the same distance they'd covered the day before. Sometimes the steel simply couldn't take it and snapped deep inside the hole. Retrieving broken pieces from several kilometers down was nearly impossible. Every major breakdown meant months of enormous effort wasted and starting over slightly beside the previous borehole. Part 2, discoveries that changed everything. But when scientists finally succeeded in extracting samples from record depths, a surprise was waiting that nobody had anticipated. They found water. That alone was enough to shock the scientific community. The prevailing theory held that solid rock at these depths would allow no liquid to seep through. But reality was entirely different. Not clean water, of course, rather a hot, bubbling solution saturated with minerals under such enormous pressure that it instantly converted to steam the moment it entered the borehole. Then came the bigger discovery. In samples extracted from depths exceeding 6,700 meters, biologists found traces of life. Fossilized remains of microscopic organisms, 24 species of ancient plankton, preserved inside rock 2 billion years old. The question that baffled everyone: how did these fragile biological structures survive in conditions where rocks themselves begin to melt? And what does this mean? It means simply that life on Earth began earlier than we thought and extended to far greater depths than we ever imagined. The surprises didn't stop there. With every new meter drilled, flammable gases rose alongside the hot water. Hydrogen, helium, and methane poured up from the depths, turning the drill site into a permanent danger zone. Workers monitored sensors around the clock, because a single spark in that gas-saturated atmosphere could trigger an instant catastrophe. Part 3, the sounds that terrified the world. A terrifying story spread through the Western press. Soviet scientists had lowered an ultra-sensitive microphone into the borehole and heard sounds that defied explanation, sounds resembling human screaming. Some described what they heard as the sounds of hell. The truth: acoustic sensors were indeed installed in the borehole, but for purely engineering purposes, to monitor drill performance and detect movements in the tectonic plates. The problem was that dense compressed rock behaves like a giant amplifier. Any slight movement in the granite layers, any creak in the metal pipes, transforms into distorted, terrifying sounds. The drilling fluid pumps produce rhythmic pulses, the turbine motors add their hum, and the result comes out sounding like the moans of a crowd. The project's former director later confirmed with clear sarcasm that what actually happened was interesting in a completely different way. Once the drill suddenly sank into a void that wasn't in any calculation. Pressure spiked abruptly and released a strange acoustic shockwave. But the explanation was purely geological. A pocket of compressed gas had exploded the rock from within, creating a cavity in an instant. The Earth is alive, yes, but in a geological sense, not a supernatural one. Part 4. The oceans and the thinner barrier. If continents with their thick 40-kilometer crust represent such an enormous obstacle, why not drill from the ocean floor where the crust is no more than 7 kilometers thick? That was the idea behind Project Borehole in the 1960s. Bold in its vision, drill the Pacific Ocean floor from a floating ship on the surface. But the logic that seemed clear on paper collided with a completely different reality. Imagine trying to drill a concrete slab while standing on top of a skyscraper on a windy day with 3,500 meters of water between your hands and your target, filled with hidden currents. Any vibration in the cable means the drill head has drifted hundreds of meters off course. A situation occurred that nearly ended the project entirely. An unknown deep water current began moving with unexpected force, pulling the ship's anchor cables until they nearly snapped. The drill tower started to lean, and if the cable had broken at that moment, the steel mass hanging in the depths would have torn the ship apart. The captain saved the situation with an emergency engine maneuver. And even when the drill head reached the bottom, oceanic basalt rock was no gentler than continental granite. Its hardness rivals diamond, and the drill head's teeth wore down within hours. Every time you needed to change the head, you had to relocate that same small hole in the ocean floor from kilometers above it. Japanese scientists aboard the vessel Chikyu developed a floating platform the height of a 30-story building with computer systems that held the ship in position with centimeter precision. But even that advanced technology couldn't handle what they discovered at the tectonic plate boundaries. Extreme gas pressure pushing fossilized mud upward and clogging everything. The bitter conclusion, the thin oceanic crust is better protected than the thick continental granite shield. Part 5. Horizontal drilling and the longest wells. A strange paradox. The longest boreholes in the world today are not on the Kola Peninsula. The records are held by oil companies in Qatar and Russia's Sakhalin Island. The well Odoptu OP-11 exceeded 12,300 meters in total length. But these wells don't go straight down. They deviate horizontally after a distance, running as complex labyrinths beneath the seabed in search of oil layers. The engineering challenge here is entirely different. Imagine trying to guide a flexible needle from a neighboring city to precisely hit a thin layer deep in the earth. Knowing the needle itself may behave unpredictably. It actually happened. During the drilling of one of these ultra-long wells, the drill head suddenly stopped responding to commands and began rotating in the opposite direction. Engineers initially thought they were facing an unexplainable phenomenon. The explanation came later. The extremely long pipes had accumulated massive torsional energy and transformed into a giant spring. When the drill head hit an obstacle, that energy released all at once and nearly tore the entire system apart. Part 6. Drilling creates enormous voids. Vertical drilling isn't the only thing humans do to the Earth. Some mining operations have left behind holes the size of cities. The Mir mine in Yakutia, Russia, exceeds 525 meters in depth and is officially listed as a no-fly zone. Not merely a precautionary measure, but because the enormous volume of cold air inside the pit creates powerful downdrafts. Any helicopter flying over it finds itself being pulled inward, like a straw caught in a whirlpool. At the bottom of these mines, trucks the size of 3-story buildings roll slowly along winding roads. From above, they look like insects. Brake failure in one of them means an unstoppable disaster. Incidents of this kind have occurred, and some drivers survived only by instantly steering their massive vehicles deliberately into the rock wall. Deep mines develop their own unique climate too. When it's scorching hot above ground, the bottom can be shrouded in fog so thick that drivers can't see anything in front of them. At the Bingham Canyon mine in the United States in 2013, 65 million tons of rock slid at once. Seismic measuring devices recorded the event as a small earthquake. Everything humans have ever drilled, every well, every mine, every tunnel throughout history amounts to nothing more than scratches on the surface. The Earth's crust is 40 kilometers thick above the continents. We haven't even reached its halfway point. The reason isn't lack of will or money alone. The physical limit is clear. At a depth of 15 kilometers, a steel pipe column will collapse under its own weight before reaching its target. We have hit the ceiling of what the materials we build our tools from can withstand. But scientists haven't given up. Project M2M is currently in development, its goal being the first direct contact with the Earth's mantle in human history. The tools being developed this time aren't steel pipes, but autonomous robots designed to operate in a literally hellish environment, temperatures exceeding 300 degrees and pressure that crushes steel. The real danger that concerns some researchers isn't technical. If we succeed in breaching the layer that traps heat and pressure beneath the ocean floor, nobody knows with certainty what happens next. Right beneath your feet, 40 kilometers down, flows an ocean of molten rock filling 80% of our planet's volume. We've sent spacecraft beyond the solar system, but we still haven't looked at what's inside us.